Okay. I'm going to be presenting on building business solutions to AWS tailored towards Disrupt Incorporation. So Disrupt Incorporated needs to accelerate product delivery while maintaining their best-in-class security, reliability, cost control, and environmental sustainability. The challenges that Disrupt has had is they've currently wrestled with fragmented on-premise GPU clusters that cannot scale elastically during model training. And they also deal with manual pipelines that consume around 40% of their engineers' efforts, unpredictable latency when during peak loads, and they have no unified cost or performance dashboard. Now, what this means is they lack true elasticity, so they cannot automatically right-size their resources. They do not have high availability, which will be greater than 99% of time, and also they lack observability. All of these are essential operations for modern AI operations. Now I'm speaking with um, Mr. Gadiel, the head of AI Solutions. He confirmed to me that waiting hours for training has not had their training speed. He said, and I quote, waiting for us for our training hampers our innovation. We cannot afford these delays in competitive markets. Our production API timeouts during our largest customer campaign. This directly impacts our revenue and customer satisfaction. We cannot track cost per model or clients in real time. It's impossible to optimize budget source credit visibility into our AI spend. And as such, we have decided to build a foundation for success using AWS well architecture pillar. Our solution is built upon six of AWS fundamental architecture framework, and the goal is to ensure that we have excellence, operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. The architecture that we have designed to carry out these for this route is using the AWS Unified AI platform. We'll be using AWS SageMaker for to manage model training, hosting, and to accelerate development cycles. We're using AWS View for serverless ETL pipelines for seamless data preparation and transformation. So we will be able to clean and prepare the data faster. We'll be using Amazon ETS for containerized microservices and flexible deployment and management. Also, we'll be using Amazon Aurora Serverless for metadata and user profile storage. And finally, we'll be using both Amazon Quick Insight and Grafana for comprehensive analytics and monitoring dashboard. So disrupts can get real-time insights. For these, the well architectured pillars will lead to operational excellence. It's saying that we'll be using infrastructure as code, relying on AWS cloud development kits and cloud formation templates. So our environments are repeatable and consistent. So moving from one training job to the other would take less time since we are essentially spinning up transferable containers again and again. Also, we'll be using AWS CI/CD automation pipelines, which is integrated with SageMaker as well. So we'll be able to build, test, and deploy with speed, which will then reduce manual errors. Then for monitoring and alarms, we decide to use Amazon CloudWatch for proactive issue detection. So CloudWatch dashboards with automated alarms will provide so real-time visibility and immediate alerts whenever we have critical errors, and which will mean that engineers will be able to tackle these issues before with minimal downtime. And for automated roadblocks, we'll be using Nessus automation to streamline incident response and outline operations with predefined executable playbooks. In regards to security, we'll be using IAM and AWS single sign-on to enforce least privilege access and thereby centralizing identity management across the entire platform. Secondly, for in terms of data encryption, we'll be using TMS-backed encryption for data at rest and CLS in transition for all services protect sensitive information. This would mean that even when data is being transferred, they will be they will be protected and encrypted. Then for network control, we'll be using virtual private cloud endpoints, security groups, and network access control lists. Finally, for threat detection, we'll be using Amazon Guard Duty and Amazon Inspector to continuously monitor for anomalies and vulnerabilities on our EKS worker nodes. Now, with regards to reliability, to guarantee uptime, we'll be deploying SageMaker model endpoints and Aurora Global Database across multiple availability zones. We'll also be enabling auto healing with EKS, Costa Autoscaler, and Amazon Route 53 health checks. This will help ensure that services self-recover when there are failures. We'll then implement continuous backup using Aurora Snapshots and AWS S3 Visioning, which will provide a robust data protection and rapid discovery. Finally, we'll be conducting chaos engineering experiments with AWS fault injection simulators to simulate and validate system resistance under failure scenarios. This will help us identify weaknesses and solve them, mitigate and create mitigations for them before they even arise. To boost performance efficiency, we'll be using managed sports training, which will significantly reduce training costs and will accelerate our experimentation cycles. While since sports instances are significantly cheaper than on-demand instances, it will reduce how much we spend when we are trying to just run simple experimentations and prototyping. We'll also be using um, elastic inference to accelerate and reduce it. Sorry, my apologies. We'll be attaching elastic inference accelerators to reduce GPU cost for inference. So we'll only be attaching GPU acceleration when we need it, which will then optimize both resource and our time and our usage. So reducing cost once more. Also, we'll be using Elastic Cache for high-speed caching, which will be useful for rapid feature store lookups and reducing data retrieval latency. And lastly, we'll be using SQS and Lambda enabled non-blocking data workflow for asynchronous pipelines, which will enhance our system's responsiveness. We believe that we can right-size the resources and rely on serverless capabilities to keep the latency low and ensure high performance even when under peak performance for long stretches. In terms of cost optimization, would be we are projecting to get 70% cost savings, which will be realized through our plan to use spot instances and savings plans for compute and storage. We expect about a 90% in optimization for storage tiering, which we'll then achieve using S3 intelligent tiering and Glacier for efficient data archival. And we expect we will have $0 spent on wasted resources, which will be minimizing with AWS budgets, Cost Explorer, and trusted advisor recommendations. We plan on integrating continuous cost monitoring and granular tagging strategies, which will allow us to track spend by each project, each model, and each team, which will enforce accountability and drive ongoing optimization. For sustainable operations, we'll be utilizing serverless first. We'll favor serverless and on-demand services to eliminate idle resources. And then we'll prioritize AWS regions that are powered by renewable energy, like Stockholm or Oregon. We'll be implementing S3 data lifecycle transitions to Glacier Deep Archival for cold data, and we'll be tracking report emissions via AWS Customer Carbon Footprint tool, which demonstrates disrupts commitments to green innovation. So these are the integrated AWS services that we are proposing to use. We know the AWS has the comprehensive platform that integrates key services and concepts covering essential areas from modern AI deployments. We our comprehensive platform integrates these key AWS components covering foundational cloud concepts, shared responsibility, elasticity, on-demand provisioning, as well as core services for workloads like batch training, real-time inference, and analytics. Such unified approach will empower your team to deliver user-centric AI solution reliably, efficiently, and in a cost-effective manner. So, for more context, we can give you a bit of deep dive into SageMaker's workload. So, with SageMaker, you have a studio IDE for collaborative notebook with version control and seamless integration. We also have training job across, which can be distributed across through GPUs and manage sports instances, which will boost cost efficiency that we promised. Also, inference endpoints for that you can auto scale real-time batch endpoints for flexible model saving, and also model registry, which is centralized up to track model versions, and automate deployments. So SageMaker is the backbone of our platform, and we should what's the providing a comprehensive set of tools that encapsulates the entire AI workflow from deployment to production. For monitoring and observability one more time, we are using CloudWatch metrics and logs, which will are custom metrics for model accuracy and drifts, which provide insights into AI performance. So you can watch for concepts and model drifts. We'll also be using extra tracing to visualize calls within ETS microservices for comprehensive performance debugging. Our security hub will be using a centralized dashboard for unified views of security posture and compliance status. And also we'll be using AWS config for continuous configuration and compliance, which will enable us to swiftly identify and remediate misconfigurations. In terms of adhering to compliance and regulatory standards, will adhere to payments card industry data service protocol for payment handling. Would implement GDPR, which is the General Data Protection Regulations, and CCPA, which is the California Consumer Privacy Act, for controls of user data. We'll also be maintaining immutable audit trail with AWS Cloud Trail. We'll be scheduled pen testing through AWS approved tool and processes, so we can always track what we're doing. Also, to ensure we'll ensure data residency with our global database region replication, so data doesn't have to leave their specific region and for their regional requirements. Our framework will integrate stringent controls, which will ensure full compliance with international regulatory standards and safeguarding sensitive data across all regions that you are available. So, for artifacts and best practices, here are the real artifacts demonstrating our adherence to AWS best practices. We use a CDK code snippet provisioning and encrypted ETS clusters, provision encrypted ETS clusters only. We'll use CloudWatch alarm configuration, JSON, for API latency thresholds. We're using a simple guard duty finding and our automated response label. And finally, YAML expert, except defining our SageMaker training pipeline, which illustrating an end-to-end infrastructure as code. These reward artifacts will demonstrate how we are complying with your operational excellence, security, and efficiency across our AWS environment. For the business impact, we expect that your training time will go down by around 70%. And we expect that the inference will be half with a 50% increase achieved through optimized model and elastic inference and auto scaling the endpoints. We expect to lower costs by 40% compared to the current on-prem GPU clusters that are being used. And we are expecting stakeholder feedback satisfaction because in our tests we've gotten that the new deployments now takes minutes and clients are now onboarding users faster. So our recommendation and next step is this AWS centric architecture addresses disrupts core challenges by providing elastic, secure, and cost-effective AI infrastructure. We also recommend that you approve the AWS budget and business support plan. The kickoff is one to deploy a prototype pipeline within 2 weeks of this presentation. Engage in AWS well-architected review to validate settings, and then roll out team training on new CI/CD and security workflows. This roadmap ensures you deliver the disruptive AI solutions you are known for on time, within budget, and with the highest standard of reliability, security, and sustainability. Thank you, and I look forward to answering any questions you have.